A 15-pound suitcase A is released from rest at C. After it slides down a smooth ramp, it strikes a 10-pound suitcase B, which is originally at rest. If the coefficient of restitution between the suitcases is 0.3 and the coefficient of friction between the floor and the suitcase is 0.4, determine A, the velocity of A before the impact, B, the velocities A and B after impact, and C, the distance it slides before coming into a rest. So let's start with A. The suitcase slides down a smooth ramp. So we'll use conservation of energy. T1, T initial, V initial equals T final, V final. Now, originally it's a rest, so that's 0. And we have MGH. And we have the final height is 0 if we put the datum at the bottom. And then we have 1/2 mv squared. So mg is 15, h is 6, 1/2 15. Now that's just mass, so we got to divide by 32.2, and then velocity squared. So the velocity is equal to 19.65 feet per second. So part B, now that it's down there and they collide. So we use conservation of momentum now. So conservation of momentum is MA VA initial plus MB VB initial equals MA VA final plus MB VB final. Initially, B is at rest, so that goes to 0. So we have, and I'm going to multiply both sides by G, so I'm going to be able to use my 15 and my 10 without dividing by 32.2. So we have 15 times V initial, 19.65, and MA is 15 again, VA final, plus 10 VB final. So we have two unknowns here, so we need our second equation, which uses the coefficient of restitution. So E is equal to VB final minus VA final over VA initial minus VB initial. 0.3 then is equal to VB final minus VA final over 19.65 minus 0. So multiplying that over there and then moving VAF final over, we get VB final equals 5.9 plus VA final. So now we have two equations and two unknowns. Substituting this here into there, we get 294.8 equals 15 VA final plus 10 times 5.9 plus VA final. Then multiplying this all out, we get 235.6 equals 25 VA final, and VA final equals 9.4 feet per second. And VB final equals 5.9 plus 9.4, 15.3 feet per second. Going on to part C. Now we have B sliding at 15.3 feet per second, and friction is all that's on the bottom slowing it down. So we got the force of friction that way, we got a velocity that way, and we have, of course, the normal and the g, but we're going to sum the forces in the x and not the y. So the force of friction then is equal to the normal force, which is equal to mg, which would be 10, times the force of friction, or the coefficient of friction, which was 0.4. And so the force of friction is 4. And so if we use conservation of energy then, T initial plus the sum of the work is equal to T final. Now T final is 0. T initial is 1/2 mv squared. And the work is the force due to friction times the distance. So force times distance equals 0. So 1/2, the mass is 10 divided by 32.2. The velocity is 15.3 squared. And that equals, this is going to be, the force is negative, so we'll move it to the side, and we get 4 times the distance. And solving that, the distance equals 9.1 feet.